Let's talk about this survey. Talk a bit about the survey and some of the major findings.
The industry is coming to grips with AI, and we think about what you need to build, how you need to think about scaling it, securing it, and ultimately how enterprises are going to engage a company like Akamai to ask us how we can help fit into their overall architecture. We wanted to get a better feeling from technologists across the globe and across industries, how they were really thinking about the readiness that they felt themselves, how their teams and their organizations felt about AI, what sort of challenges they were going to be facing. And basically, as we think about the adoption of this critical capability across a number of different sectors, what were the things that basically kept them up at night? What were they the most excited about? And ultimately, where could distribution help them? And we got some really, really interesting answers.
Can we talk a bit about, of course, we can go with some of your findings, but I have one query before we go into your one is that when we look at, of course, these days, most of the time pilots fail, but when AI moves from pilots and chatbots into real production applications, what changes there where enterprises have to start thinking about inferencing architect differently than just doing some pilot projects?
Well, I think the biggest thing that we deal with a lot is as the industry is thinking about moving away from just purely leveraging AI factories, because a lot of the early practitioners, a lot of the early scaling of AI, and something that Jensen Huang talks about even at his GTC conferences for NVIDIA, is that the centralization of compute so that you could get access to the cards that you needed, you had access to the power and the space and the ultimate ability that you needed to scale to the token consumption that a lot of the frontier LLMs have been leading the industry with. People just assumed that as they started to move to production, it was going to be like training, but faster. And that's actually not true. It's not true that if you can just train your model, then you'll be able to serve it to people at scale. And there are a number of different reasons that we've discovered this. One reason is the training of a large language model and having, hundreds of millions of weights, for example, that are inside of this model, is that many times people don't need all of that wealth of knowledge to be readily available inside of the model. In some cases, you'd be much better off having fewer weights, a smaller model, something that you can ask a domain specific question to and not worry so much about the sorts of things like how long it would take the query to return or if there would be hallucinations because too much information was inside of the model that you're accessing. But that's not really the main problem. The main problem when we think about going from training to actually leveraging something for inference is that you're solving for a completely different infrastructure problem. And when you treat them the same way, your AI program is likely to stall or fail. And the reason is training is a concentrated activity. It's predictable. You have a certain latency tolerance that you typically will build into a project when you are training a centralized model. You create the dense CPU cluster you need. You let the queries run. You let the training algorithms run, and you optimize them for throughput for a certain amount of time or to reach a certain, a capability that you're trying to train for. But in the case of inference, it's exactly the opposite. You're training for a distributed, bursty, and really sensitive sort of a workload that is completely dependent on the user asking a question and expecting a response. So every response today is either a real person or a real agent that's waiting for an answer. And every time that you add latency to that equation, you can see that, businesses are experiencing the sort of challenges that they experienced in client server interactions because the way that you're interacting with an inference-based chat experience, in most cases it is still a chat medium, is expecting that instantaneous result, and you just can't get it when you plan for that centralized model.